So I wanted to bring up the people who've been involved in this project. Originally, Ping Tao, who did the original work for EMC, but is no longer involved. I wanted to thank especially Frank Zagos. He's not here today, but he's done a wonderful job of becoming very active in this work and helping share the responsibility. This is a huge amount of task. If you look at a lot of the commit lines that have been changed or deleted over the years, a good chunk of the Lustre changes is due to this kind of stuff, removing the wrappers and all of these methods. So what's the goal right now? What I've been focusing on for the last 2 years is to make, because of the divergence, is to make them re-merge the trees. So this way we can easily migrate and bring our clients and hopefully one day move to a position where we can use the upstream client as the code base instead of the Intel branch. The Intel branch can be then just a wrapper or some kind of construct where you could support the distributions which are always behind the Linux kernel. So in order to do this, you have to do things like support a newer kernel. We have to continue removing all these wrappers. One of the things is this Lustre is a very old product, 10 years now, 10, 15 years. So because of this, it developed a lot of things that were lacking in the kernel. For example, a lot of the stack tracing stuff, memory allocation leaks, that kind of infrastructure didn't exist in the Linux kernel 10 years ago. Today we have this kind of infrastructure, but we're not using it. Trace points is a good example of what could be used and should be used in the future. So we have, so what has changed since master? So where we're at in the Intel branch, we're up to the 3.15 kernel support. It's a little lagging because we've been focusing on updating other parts of the tree and cleaning everything up. We finished the proc mess. So a long time ago, the proc file system didn't use sequence files as the backend, and we didn't use that, but now it only uses that. So we had to do this incredible amount of porting and moving over to that infrastructure. All the CFS wrappers are finally gone. We had everywhere CFS, atomics, and lists everywhere throughout the code. Probably 50 to 100,000 lines of this stuff. liblustre is gone. So liblustre was the thing to use for the user land Lustre support. So if you didn't want to run it in kernel space, that has all been removed. And of course, now, after the last few years, we've enforced the enforcement of the kernel coding styles. So every time a patch is submitted, it goes and it's being checked to make sure. And the reason this is done is because there's so much overturn in the Linux the Lustre kernel code is that this allows it to be formatted properly. So by the time we're done, we don't have to submit a 3 million line patch to indent everything and do it to the specification. So there are two parts of this project to upgrade it. There's the server part and the client part. So the benefit of doing this work is that we've actually, all the code cleanups, the wrapper removals and everything have actually impacted the server side. When the day comes when we can move the server code upstream, it will be a very seamless act. So, but we need to focus, there are still parts of the server code that isn't there yet and that we need to do for the benefit to make it easier, and it's such a burden right now to support this stuff. So right now we have to patch on the server side the Rail kernel to support various test options. So when you do run it through the test suite, there's these patches that allow you to run it through the test suite to simulate failures, things like that. That's the RAID 5 multi-mount option. We also have a way to simulate failure of disk where it can't write to it. It's the dev read-only patch. These are very non-standard ways of doing things. So we've looked at removing a lot of this and making it so it's an ease to the system administrator that they can just update their Rail kernel on the server side. They don't have to patch it or go and get the Intel specific one. So that is what we're looking for. So the server side would be patchless. Right now, you can do this with ZFS. That's the blessing of ZFS. You cannot do this with LDiskFS at this moment. But the patches are dwindling down. So basically now, in fact, one of the things that will be shortly introduced is except for the quota limitations, there's quota performance, but those have been even introduced, matter of getting those backported. And I believe Rel 7 has those patches. So basically all you need to do is do testing patches. That's covered under LU 3406 and under LU 684, which would remove needed patching of the kernel, and we can use the device mapper flaky module, which allows you to inject failures into the disk. So those are hopefully what we get. Everything has been moved upstream that we want to, except for LU 3406, which is the multi-mount protection patch for the testing of that. And that will require more work. That was pushed upstream, but it was rejected, and there's a lot more technicality to that. The other area that is a huge change is the LDiskFS. Right now, we have reduced, the number has been reduced, but there's still about 15 patches or so to do. A lot of these can be pushed upstream, and these are going to be pushed upstream over the next year. I know Andreas is going to be giving a talk at the Linux Developer on Thursday about this process, actually starting to go on. So, and the other thing is the LDiskFS patches themselves could actually be simplified, and that work has been going on. There were patches that were no longer needed, and we could use infrastructure in the ext4 file system. So, what needs to be done to merge the branches? What is left on the client side? This is all being tracked down under LU 6215, and basically we have to synchronize what has been done upstream. Things like type def, there's a lot of C formatting that was done that was not like C99 compliant and things like that from the old days. We have to change those. So we have several tickets open up where we're being done. A lot of good progress is being made on like especially the first three actually. The other one is, believe it or not, they're picky about spelling and grammar. Yes, you laugh about that, and I am a very bad violator of this. I'm very bad. But thankfully, Frank Zagos, which knows English better than me, and he's not a native speaker, has been cleaning that up. So we've been doing a lot of that. There's also another thing that was a problem was in the LDIS. With a lot of the Lustre system was we exported everything. We don't need to do that. And the last thing, and then there's sparse cleanups when you submit a Linux kernel patch, you can run it through a check patch to make sure it formats to all the coding styles. And the biggest and the ugliest thing is the tabathon. Yeah, we've done about 30 to 40% of everything from the space to tab. But that's a huge amount, and they are very picky about those kind of things. So what is left besides all that cleanup, which we are now synchronizing between the kernel upstream client and the Intel branch? Technical debt is left. A lot of technical debt. Actually, if you don't realize it. So the two main areas where the technical debt is extremely bad is libcfs. So libcfs was this container of things that were supposed to be shared between LNet and Lustre. And it contained the kitchen sink of everything you can imagine. And the worst part was it was because it was a user LAN and a kernel space thing, it had all these wrappers and constructs to use to support both platforms. That is gone. So, and in the Linux kernel, one of the specifications of headers is the use of the UAPI, which is the user LAN API. So they've separated their kernel space headers, which are supposed to be only used internally, and their headers for user LAN, which are exposed to use. libcfs is totally not like that. It is intermingled and twisted in a where you cannot say if you try to pull out one thing to do another, it breaks user LAN as well as kernel space. And one of the other big things that we do, which is quite an abomination, is libcfs.h. So in the old days, you just included one header for all your source code everywhere. Not a bunch of headers for what you needed. So libcfs was the catch-all. You put all your headers and all your definitions in one giant file. And so, and that file, is included in both userland and kernel space headers. If you write a userland application like libLustre API, you use that header. And use that header in kernel space. So there's a lot of that. There's also abstractions left, which are being removed. So actually, we've made pretty good progress in the 2.8 series about this. A good chunk of it is cleaned up. But what else is left is also the Lustre header train wreck. That is the same problem as libcfs. Livermore could tell you, they file tickets about that where you couldn't compile Lustre IDL.h and all kinds of mess because it pulls in all this kind of junk. It is quite a nightmare. There's no, the intertwining is, and then there's internal Lustre files being included like lustredis.h. And so those things have not been addressed yet. It's just starting. Frank Zagos is starting to look at that. Andreas did some work with that. He sent me some patches. So that work is going to be started, but right now libcfs has been the major release, and there's a very specific reason why. So if you look at the amount of time, the estimate of this work, I would say there's at least 6 months of solid work on this that we're doing that's going to be needed in the future. So what prevents Lustre from getting out of staging? So that's the other question. Why is it still stuck in staging 2 years? And the reason is because of what some of the architectural designs we've done that they don't like. Job ID handling. If you remember, there's a subsystem where you can get statistics about jobs being employed. The approach of doing that is disliked. The random seed handling. There's a PRNG file in there that handles generating random numbers, and that was written such that it's for both userland and user in kernel space, and because of that there's some things that are not kosher with it. And the other big one is the dislike of procfs. The tendency is the desire is to move everything to sysfs. So this is very lacking, and all our code right now is all procfs. Our tools are totally dependent on procfs. And we did an investigation. I had Chow at the lab, who works with me, look at this. And in 40 different places in the Lustre code, in the userland code, is individual different access to the proc interface. So there's no standard library call or anything to point to where to get the procs values. And of course, there's the trace point instead of the current debugging system, and there's other tools that the Linux kernel now possesses that we could move over to. So even with all the syncing that we're going to do and make the Intel branch ready, we have to address these issues, and these issues have to be applied both upstream and to the Intel branch. Oh, it's no longer a concern now? Ah, good. So how do we go for staging and address all these issues? So the biggest, I think the process has to be broken up. Lustre code, if you look at it, is gigantic. It's larger than any of the other file systems in there. And even though Lustre lacks a lot of modularity, there is some modularity to it, and it is a layer on top of the LNet layer. I think the best strategy to do is to move to disintegrate, to get rid of libcfs, or minimize it as much as possible, make it a subproduct of LNet, and move LNet out into the networking layer for Lustre, for the Linux kernel. And I actually believe that could be done probably by the next log. That is a very reasonable goal. And the nice thing about LNet and libcfs is, until recently, it does not see a lot of change to it. There's not a lot of bugs left in it anymore. So it's a very realistic, whereas the Linux client is constantly, the Lustre code client is constantly on the move right now, especially with the Clio cleanups and stuff like that. So for the Lustre client, which is the next stage, we have to consider all the design issues. And I'm hoping that by 2017, that will be all completed. And of course, the last step is to merge in the remaining server-side support. And those are the 3 stages I'm hoping to see going. So I made it a pretty short talk, especially since it's near lunchtime. So what is the work left? We have lots of style issues, spelling problems. These are things that do not require a high bar, and if you want to get really exposed to contributing, this is the way to go. This is how I got it. It touched all kinds of layers of code and that. It's a really good way to get involved. Same with the libcfs work, needs lots of work. We've developed probably 15 plus patches just to clean up the headers. There's also the internal code of the libcfs that needs to be really cleaned up. And we need to have, the other big problem that we're missing is the upstream kernel itself. And actually, that's one thing I wanted to give a thanks to Oleg. Oleg has been the sole person dealing with the upstream branch and merging in patches. And that is a lot of thankless work. So what we need to do is help Oleg out and start to become involved, especially as we see things like LNet and libcfs start to mature and get ready to be merged back in, those changes. And of course, we always need, there are people I know, I see them on the mailing list, who are running the latest Ubuntu, or they want to run a 4.0 kernel. If you can make it work, and please feel free to submit your patches for it. We will gladly take them. So don't feel shy about this stuff. And this is a huge, huge project to sync up these trees. This is going to need a lot of effort, and especially on the upstream kernel side, it's been very, very lacking. So I would love to see people get involved. And that's it. Any questions?
What kernel are you targeting? What kernel are you targeting for this work?
Right now, 3.15 is the latest I've gone to for that work. I usually test on a 3.12, and there's reasons because I do the Celeste 12 support as well and work on that. And then the 3.15 I've been doing. I have recently started to do a setup, but it takes time. I'm starting to build a Greg Knorr's next tree, actually using that. I've been in discussion with Oleg about setting that up and testing that for the latest client.